Okay. Do you hear me well there in the back? Yeah, thank you. Okay. So welcome everybody. I hope you had fun tonight and the hangover is gone already, or at least that you had some coffees. This is a beautiful picture, and the title of the talk is "Why Do Lazy Developers Write Beautiful Code?" And the material I'm going to expose are just my opinions. The contents is highly subjective, so maybe you don't agree. These are mainly my opinions. I have read many of these things from other people, but are my opinions. And we are not going to discuss about deep details of Python or any other tools or languages. We are going to move more in the world of the ideas and the philosophy. So, for this reason, this is the most difficult talk I think I have ever prepared. And this very first slide is an example. This is a beautiful painting, but given the title, I don't know what is more important, the beauty or the laziness. And for this reason, this would be the alternative first slide. Do you know why being lazy can be a good thing for a developer? My name is Javier Arias, and I'm working on improving my laziness. I work as a senior software engineer at Skyscanner, and I think the word senior is because probably I am the oldest member of my team, the gray hair and these things. And in fact, something like 2 months ago, a colleague of mine, who is 20 years younger than me, started calling me Papa. And the worst thing of it is that I liked it. So I started working in the industry about 20 years ago. And at that time, I was like a cool guy. I was working at a very small startup, and I was so cool that I was working in Java. This is what cool guys did 20 years ago. We were so cool that we even were using a version control system. And it was better than Git, in fact, because you could not have any merge conflict, because whenever you wanted to work with a couple of files, you checked them out, and then they were locked. Nobody else could edit them. So maybe some another colleague was like annoying you, hey, are you done? Are you done? I need those files, but there were no conflicts. But what I want to share with you about that first job in that startup is not how cool I was, which I wasn't, but what we're working with. We were creating a case tool. Do you know what a case tool is? In a case tool, in a case tool, you are expected to be drawing a diagram and then generating code. Hopefully, you can then go and modify your code and then reverse engineer it and have both things like synchronized. They were very popular 20 years ago, and they were influenced by other fields, such as build engineering and construction. So the idea is that you created this diagram, then generate code, and it was matching very well with waterfall methodologies. When you work in a waterfall project, you prepare like a big plan. 20 years ago, projects were much bigger than now in general. So you started by preparing all the requirements of your big project, and then you stopped the requirements. You started with analysis for the whole project. This was maybe 10 analysts working just on documentation. Then they stopped analysis. They started with design, which was closer to the development. Then they finished, and maybe 6 months or 1 year later, the developers started coding. This way of working in sequential steps, not going back, was working very well for construction and for bridge building, these kind of things. But I have seen these kind of projects fail many, many times due to overrunning time, to over budget, or maybe just with products that are not making happy our users. They don't want to use them. And anyway, they were released. We have been working in this shit for 2 years. So there is no way back. So I was wondering why is different software development to construction, and why is it that this waterfall process is not working? And I think the main question is that software development is a wicked problem. A wicked problem is a problem that can only be solved by starting to solve it, because there are so much uncertainty that you cannot solve it by thinking ahead. So it's like being in a maze. You are in the middle of a maze, you of course don't have a map. So you have to go and try different things, different doors, and then remember about your mistakes. Whenever you are in a place you cannot go away, so you have to go back and then start again until you find the solution to the problem. And I think it's very similar to what happens with software. So it seems that construction or bridge building have no so much traits that we can learn from. Or maybe there is one. There is one thing that we can learn from bridge building. And I like this quote very much. And it says that the best engineering is born out of the imperative to use the minimum amount of materials. And I think that we can learn from this that we should be using the most simple things, less moving parts, and should strive for simplicity. So then I went on thinking, and maybe software is like science. So scientists are also dealing with wicked problems. They have a lot of uncertainty, and in fact, that is the reason why the scientific method is not a sequential step like waterfall. Scientific method is based on iterating. So what you do is you have an hypothesis, you do an experiment, and then you try to analyze what are the outcomes of the experiment, and then you iterate over and over again until you reach some conclusions. So in this sense, it's more similar to software development. But there is a main difference, because I think that the main objective of science is getting to new knowledge, something that is original. And in the case of software development, our main objective is to make beautiful, useful products. Maybe it's a corporate system or a website, or maybe just a library for other fellow colleagues to use. But we should strive to have something working that is beautiful and easy to use. And this is a difference. So I was thinking, maybe software development is like an art. Art is about the skills and imagination. And so is software development. But art tends to look for beauty. So maybe if we can hack a definition of beauty that applies well to code, maybe we can feel like artists, or at least for a minute. So my favorite art to compare programming to is painting. It's not just at this very abstract level that is where we share like common traits like skills and creativity and beauty. But I think the way painters work has to do a lot with how we work. So this is difficult for me to explain, and so please let me play this video. This is when the presentation fails, but I'm going to play you a video, and this is Pablo Picasso painting a woman. Okay, so he starts here with a sketch, and please check how especially the body and the legs, are going to change during the video. Okay, so if we can imagine how we code, our current project, the code in our projects, we organize it with packages, modules, classes, functions, these kind of things. If we can imagine them as drawing elements, as squares or whatever you fancy, maybe UML, ugly diagrams, and these elements are related with different kinds of relationships, such as composition, inheritance, dependency, and what else. So we can imagine our code like an abstract diagram with many things interrelated. And many of us are using version control systems, such as Git. And if we can imagine, on each commit, we're taking a snapshot of that diagram. If we could just play a video of the different commits and the different diagrams, I think we could see how the code is evolving and moving around as we refactor, implement new features. And I think it has a lot of similarities to the way Picasso was painting this woman. Okay. Go. So as we have seen, programming started with painting, the painting by Picasso started with a sketch. It could be a prototype for us. And then started with gradual refinement. And as he was painting, he was realizing that the original idea was not right. And this is the case in software development. Many times we start with requirements that are not perfect. Not sometimes, but always. Also, maybe the requirements are good, but as we develop and as we create our product, we realize that maybe there are better ways of doing it. So we have to change. Also remember, software development is a wicked problem. So we have better to be prepared for that. We have to be prepared to change our code on a very ongoing and dynamic basis. So if we go back to the presentation, we were pending of that definition of beauty that matches to code. So to understand what is beautiful code for me, first we have to understand, or I would like to explain these limitations we have in our mind. Because there is that paper from 1956 where George Miller, a psychologist, had this paper that was explaining how our capability to reason properly, it starts to decrease when we have more than a number of concepts in our mind. It seems that it's something similar to 7. I think in my case it should be something like 2, but the number is not important. The important thing here is that this explains how we work solving problems. So we have that big problem that we want to solve, so we slice it in smaller problems. And if these smaller problems are still too big, we slice them again in smaller problems. So we start coding and solving those small problems, and then we compose the solution back for the big problem. So this way of working is not imposed by us, to us by machines. A machine can just handle a single file with 1 million lines of code, and it will not complain. It is us who need this organization and this way of organizing the problem. So beautiful code is not something abstract like in painting or photography. It's not just beauty. One of the very first characteristics that are important about problems, about code we have written, is that it has to solve a problem, and we have to check how well it is solved by this code. But also, I think that beautiful code is meant to make us more productive and happy. What I try to mean is that if we have unreadable bad code, our productivity will be bad, of course. And probably we will be more unhappy. On the other way around, if the code we have to deal with is easy to read, is easy to understand, our productivity will increase, and we will probably be much more happy. So I can see beauty in this code that is easy to understand, that is easy to read. And I think that this is the main objective of the beautiful code. So I'm going to show you some quotes from different people about what they think, what beautiful code is. This is Yukihiro Matsumoto, the Ruby creator, but I wanted to show you this picture of him with a Python t-shirt. And he talks about many points, about brevity, familiarity, simplicity, flexibility, and balance between them. He was comparing beautiful code to writing an essay. Also, there are others that think that beautiful code is like a joke. If you have to explain it, it's bad. And of course, we are all Python fans here. For me, this is a source of inspiration always. And many times we have design discussions with other colleagues, and then we go to the theme of Python and check by order from top to bottom the different sentences. And it always helps to solve some design discussions or some kind of disagreement we may have. And I think it's so well written, as talking about all these things, about beautiful, about complexity and simplicity and readability. And if it's something is difficult to explain, probably it's not a good idea. And it's so good. And also Ken Beck, who is, I'm a big fan of him because he goes always to the essence of things. He thinks that good code has to pass the test. It does what it has to do. Ravel's intention is a very well-written way of saying when you read it, you understand what the original programmer was intending to do. There is no duplication and fewest elements against simplicity. And one other important reference for me is always Uncle Bob, and his main summary in code reviews. So the less WTF per minute, the better the code. So I would be happy if, at this moment, at least some of you can agree that given that our code, what we do, can be beautiful, and we have to work this iterative way by modifying our ideas while we are working, I feel like at least some of you can agree that we can feel like artists when we do our job, or at least during this presentation. But to do this, to feel like artists, we have to write beautiful code. And come on, we are lazy. We don't want to write that beautiful code, because why the hell do I have to write tens and tens of small functions with long names and long variable names? When I'm talking about laziness, I'm not talking about not wanting to do our jobs. I'm talking about be very careful and strategic to where we work, to what we do, to not lose our time doing things that are worthless. And there are some tips for lazy developers. I will rush through them because I'm running a bit out of time. So first thing is to use the right tools. I think that Python is probably the best language if you want to work in such a dynamic place. We have to optimize for development time, not execution time. Then when you have something working, maybe we can load test, do whatever you need, improve it, and okay. we have to be pragmatic. We developers tend to be fashion victims. We like to test new languages, new tools, very exotic databases. And we have to restrain about that, and we have to be pragmatic and try to keep the things simple. We have to automate everything. Okay? If you do something more than 2 times or 3 times, it's a very good candidate to be automated. I guess that none of you like to test your code manually, and even not doing it every day, because we are working very agile. We have to push code every day, so we don't want to do that. Please let machines do these things for you, and packaging and deployment. All of this can be done by machines, so don't lose your time doing stupid things. Lose your time doing interesting things. And fast feedback is the best thing. Do you know what lean startup, continuous delivery, and TDD and other things have in common? They change the way we work so that you have very fast feedback, so that you take a decision, you do the minimal amount of effort to check if what you are doing is good or not, and then you can stop and change or go on with it. Let's imagine we have that feature we want to code, and we have 2 weeks in a sprint, so we start writing beautiful code. But this is something we never did, because we have to communicate 2 processes or do something that has a bit of risk. We start writing beautiful code? No, we don't. We start writing the ugliest possible code. So we have the happy path working, and we solve the technical problem. Then we throw away this prototype or this spike, and then we start writing beautiful code, but by knowing that our assumption was right, that there is no technical risk involved. And of course, write beautiful code, please. This talk has been very heavily inspired by 2 people. One is Bill Gates, not very popular in open source, but okay, they are improving right now, Microsoft. And he would choose a lazy person to do a difficult job, because we would find a good solution, an easy solution. And also Larry Wall, the author of Perl. And he is telling that we have to be very careful to where we spend our time. And also that lazy developers automate things and write beautiful code and documentation, so we don't have to explain this code to our fellow colleagues or ourselves in the future. So this is what I wanted to share with you. I hope you enjoyed, and thank you very much. So, by the way, I work at Skyscanner. I prefer just to 10 seconds. We are hiring new developers, so if you would like to feel like an artist from time to time, we have offices in Barcelona, and we do things at internet scale, very big things. So if you like challenges, and we have nice people there, look for someone with this T-shirt, and we will be happy to talk with you. Thank you. We have some time for questions, maybe someone in Spanish, if you prefer, and I will translate it or whatever. Oh.
I heard you are using TDD and techniques like that. Are you using behavior development?
BDD. I have used BDD in the past, and okay, I have mixed opinions about it, because one of the main selling points of BDD is that you can write the tests so that business people can understand them. In my opinion, it's not always the case that business people are going to write these tests, or they are going to read even these tests. But if it makes sense for you, it's nice, because it's a very nice way of writing your tests. Maybe it's a way to have them easier to understand. But I think it's the selling point of the business people reading them is probably not the reason for buying it. But yeah. Thank you. Okay. No more questions? Thank you.
Thank you very much.
Thank you. Muy bien. ¿Sí? ¿Bien?
Sí, sí.